Hi, everybody. Okay, let's do assignment 5 real quick and show you how to do this solution. All right, this is very similar to the other one. However, there's some differences, so let's just kind of look at it a little bit. In this case here, given the radius of a circle, calculate the area of the circle. Add an exit button that will close the program. Add a clear button that will clear all the inputs and the outputs. Make sure you have comments in your code and make sure you test your program submitting. I gave you a formula here, kind of a rough formula, right? A equals pi r squared. So this basically says the area in which we're trying to calculate equals pi r squared. You may be saying again, I'm not that good at math. What the heck's he doing to me? It isn't really that big a deal, but you got to be able to take stuff like this and answer those questions. How can you do this programmatically? Okay. Not overly hard. Pi is 3.14, so I kind of gave you that. And so we just need to go ahead and figure out how to do this programmatically. If you struggle with this because of that formula, once again, don't fret. It's not that big a deal at this point in time. It's to challenge you a little bit to see where you are and so on. And also what you did with that. If you don't understand those types of things, once again, that formula, you shouldn't be sitting there going, oh my God, what do I do? You should be asking the question. If you're doing this online, I know that's sometimes hard, but all you have to do is send a quick email to your instructor and ask the question, how do I do this? I got to take this formula and break this apart somehow to do it in a program. How would I possibly do that? And we'll help you with that kind of stuff. So you don't need to know everything, and I know you're brand new to this. So once again, be patient with yourself. It's a learning process. The whole idea we want you to do is try, okay? With that said, this is what we're trying to accomplish. And of course, we wanted to put this sentence in there, which means you got to learn how to concatenate. There was a video that talked about that. So hopefully you saw that also. Okay, let's get into our design quickly. In this case, what I'm going to do is we're going to go through the process together. With our inputs, what's our inputs? Well, as you know, we have our radius. That is our input. Was there any other inputs? The answer is no. Our outputs is area, okay? Oops, let me put that up here. Area. And that's pretty much all we have. We had one input and one output. So once again, do I think you should be doing this? I'm hoping you're doing this. So you think it through first. All right, practice on the easy ones because once again, it's not going to be easy for all that longer, much longer. You'll notice actually starting next week, things start pumping up a little bit, okay? And by the time you get done with here, you're going to have several inputs and several outputs. So you want to practice designing now when it's simplistic, so you learn how to do it when it gets a little bit more complex. All right, we're going to do our pseudocode. We always start off with get. We're going to get our input, so we're going to get radius, okay? Radius, all right, if I can spell. Matter of fact, let's do this. I'm going to put my glasses on so I can actually see it. There you go. Sitting here doing this video with my glasses on, just seeing a blurry screen. All right, so my next thing is I got to solve for my output area. So my area is, pi r squared, right? And so how are we going to write that? Well, pi is 3.14, okay? And it's going to be multiplied, right, to pi r squared. And so if you go back and look at calculations and how you actually did the calculations and the symbols of it, pretty much all we're going to do is take the radius and we're going to square it. And to square it is the caret, and we put 2 there. I know some people at this time say radius times radius. That would actually work. I'd rather you get used to the caret because if all of a sudden it's pi r to the 3rd power, I guess you could put radius times radius times radius, and the 4th power is keep doing that, but if it's to the 10th power, it's going to get obnoxious if you're doing radius times radius times radius all the way 10 times. In this case, learn how to do exponents, and it's the caret. So radius at caret 2 is actually how you write this in this formula. So 3.14 times the radius to the 2nd power is actually how this would be working. If you look at the formula again, let's go back to the formula. It's pi r squared. So we want to square this first and then multiply it. Now, if I don't put brackets around it, it will square it first because once again, please excuse exponents first, my dear Aunt Sally. All right. If you did radius times radius with this, meaning if I didn't put the brackets around it, meaning that, okay, it would still do this first, right? That's beautiful. But if you did it like this times radius and you didn't put any brackets around it, interesting enough, it would multiply 3.14 to this radius first, then to it, and that would actually be wrong. All right? So the best thing to do is learn how to do exponents. Once again, in this particular situation, if you didn't do that, I wouldn't fret, but that's what I'm doing these videos for, is to help you learn this, okay? And as long as you tried, hopefully you'll now understand. I always like putting brackets around things, even though exponents would be done first, so it's easy to read. We can actually see right off the bat these two belong together, and that's what we're going to do. Pretty simple. That's your design, right? Let's take it to our program. And let's see, where's my program at? Here you go. And we're going to take it to our program. Here's my my particular form. I'll get it out, my Windows form, where I have my radius and my area of the circle. All right, perfect. Double click on this. And I got my inputs, I got my output as decimals. I go get my inputs off the screen, put it in here, and you see this is how I actually did it. All right. Putting this all together in a string, again, we're doing a string and we're concatenating, we're adding to, that's what concatenating means, adding to the string. So I have an original string that goes from here to here. Notice the space right here, right? A lot of people sit back and say everything's crammed together. Well, you got to put a space in your first string. Then we're going to take that string and add to it the actual radius, the input. And add to it symbol is, in this case, the ampersand. Then we're going to have another ampersand and create another little string, if you will, with a space before it. Inches is space. And then we're going to add to the actual answer and put in there square inches. You see how that works? We introduce this like this because you do this quite a bit. I don't want to say a lot, but every once in a while you need to build a string, okay? And sometimes the string is going to be built based upon the dynamics of a variable, meaning it's ever changing, and the hard coding of an actual string. Does that make sense what I'm saying? Meaning this is hard coded, this will always be this way, but this is going to change based upon your inputs and your outputs. And that makes it kind of dynamic in a sense versus a static, hard-coded string. Kind of neat in a way if you actually look at it, all right? If that's still a little confusing to you, once again, don't fret over too much, but seek to learn this and seek to try to understand it, all right? How this works then would look like this. And if I put 10 in there as my radius, it would say the area with the radius of 10 inches is 314 square inches. Yeah, yes, okay? Clear, I can do this all over again. What's like I said, what's nice about this is that, see how these always change? That's what I mean by dynamic. The words are static. The words are always hard-coded in there, meaning it's not going to change. 66 and this right here will always change based upon the input and the output. And that's what this allows and how that works. So copy mine if you want to, and make sure you see how it works and get it to work that way. All right? One more piece here, because I know your particular problems talked about a constant. We have not reviewed constants, and so I'm going to talk about it here for 1 second, and I'm going to talk about it again next week. A constant is sort of a variable, okay? When I say sort of a variable, it's the same concept that it's actually going to do the exact same thing a variable is. When we put the word const, that's how we define a constant in Visual Basic. It's going to do the exact same thing as a variable. It's going to go and allocate memory based upon this name, based upon this data type. Since it's defined as a constant, it cannot change. That's the cool part about it. I don't get into constants too much because I don't think I write a lot of programs with constants in it anymore, because I usually use things like databases to help me with that. But we're not there. But it is important that you understand what a constant is. So a constant is a variable that can't change. You usually define all your constants at the outside of your events, okay, or your procedures. I usually do it right in the top here. Why? Because the purpose of a constant is to have it in our program, and if it ever has to change, the programmer can go in and find them very quickly and very easily. So we usually have constants sitting up here. Once again, I'll give you a better example next week in an example program, okay? So I basically set my constant to 3.14. So then what I can do here is do it this way right here. I can actually then reference that constant right here, and that would work the exact same way. If you put 3.14 here versus a constant, that's no big deal. If you follow the instructions and try to use a constant, great for you. Good job. If you didn't get it to work because we haven't covered it, not your fault. Okay, but we're going to cover a little bit as we can kind of go on. But that's all it is. Just don't make it any harder than that. Okay, a constant is a variable that can't change. So instead of hard coding an actual value, we'll put it into a constant. And what's kind of cool about it is, if needed, we could use this constant over and over again throughout the program. That's kind of what the purpose of it is. I hope that helps. Okay, so there's your solution for assignment 5. Once again, this is no time to panic. These are some of your first ones you're doing, but I'm hoping you're starting to understand, and I'm hoping these videos and solutions aid to your understanding. Even if you did it incorrectly or you had a few little snags here, hopefully by listening to this, you can get it to work yourself. Okay, good job.